Okay guys, let's have a look at question 5. We'll do part A first of all. Let's have a little quick look at the question on the paper. We've got a series of forces here with their magnitudes and directions and orientations listed here. So let's sketch that. And we're going to need to find the value of P, this force here, which is P newtons, and also the angle theta. Give each of your answers correct to one decimal place. So basically we're going to resolve the forces horizontally and see what we get. And then we'll resolve them vertically and see what we get. And we should get two equations in two unknowns, and we should be able to solve for P and theta that way. Okay, so that's the plan. So let's go back to the problem then on the sheet, and we'll draw the picture then first of all. So here's our axes. Let's draw that in like so. And then we got this one here. Okay, and then the first force that I can draw in is this one here, which was at an angle theta, and then this one here, which was down here, an angle 80 degrees, so I better draw it like that, say. And then we've got another force here. I'll write them in just a moment. We've got that one there, and then yet another force along here. We've got that one there. So let's just draw them in then. This one acting in that direction is 70 newtons. This one here, we are told is P newtons, and this angle here is theta. This angle here is 60, and this was of magnitude 90 along this direction. And this one is of magnitude 50, and this angle here is 80 degrees. That's everything. So let's resolve the forces then. Let's resolve it horizontally first, shall we, in that direction? So P cos, agreed, is that one. 90 cos 60 equals, so that's the forces in that direction, 50 cos 80, and then plus the 70 acting in that direction. So there we are. So we got P cos theta is equal to, it'll be 50 cos 80 plus 70 minus 90 cos 60, won't it? So let's just type that in a calculator then, and we can write down the number, can't we? So we'll have 50 cos 80. Make sure I'm in degrees mode, so shift modes, and we want degrees, which is number 3. So we want 50 cos 80 now, 50 times cos 80 plus 70, and then minus, because we're moving this over, 90 cos 60 times cos 60. There we go. Equals 33.6824. Let's keep it nice and accurate. 33.6824. That's equation 1. Yeah? Okay, good. Now let's resolve vertically then, in the vertical direction. So we got Pn, and this would be, this vertical component would be Pn sine theta, wouldn't it? P sine theta rather, not because it's P newtons, isn't it? That vertical component, when resolving in that direction, would be P sine theta. Then you've got, that's nothing, it's just a horizontal force, and that would equal the downwards ones, which is 90, that'll be 30 in there. 90 cos 30 plus 50 cos 10, isn't it? 50 cosine 10. So P sine theta is equal to, then, what have we got? 90 cos 30 plus 50 cos 10. So let's get the calculator out. 90 times cos of 30 plus 50 times cos 10. Bracket. Okay, that should be it. 127.1827. 127.1827. Let's just double check I've written that down correctly. Yeah? 1827, because the 6 would round up to a 7. Okay, so that's sine. This is number 2. So if I divide one by the other, so 2 divided by 1, the p's will cancel and I'll have sine over cos, which will give tan. So we'll have tan theta then is equal to 127.1827 divided by the 33.6824. Let's type that in a calculator then. 127.1827 divided by 33.6824 equals 3.7759. I'm going to leave that in the calculator. 3.7759, yeah? And then I'm going to do shift tan on that if I can. Shift tan. Oh, I can't, so let's just write that down then. So it's going to be shift tan of 3.7759. 7759. Okay, equals 75.1. Now we're doing it to 1dp, these answers, aren't we? But let's just keep it as is at the moment, nice and accurate. 166. 75.166. So I'm going to go down to 3. Theta equals 75.166 degrees. Okay, there's theta, which equals 75.16 would be 2 degrees. That's to 1dp. Now we need to work out, that's the angle then, and then we need to work out the value of p, so so I just put it in here, shall I? So let me just scratch this for the moment and give me some room. So let's put it up here, just put it in a block here, okay? Right, so let's put it in here. So sub in 1 gives, so p sine theta, p times sine of 75.166 equals 127.1827. So p then is 127.1827 divided by sine of 75.166. So let's just type that in the calculator. 127.1827 divided by sine 75. So it's sine, we're in degrees mode, 75.166. Close bracket equals 131.568. So let's put that down. 1.568. There it is there. That's an 8, isn't it? So that's good, and that would be newtons, which equals 131.6, and that's to 1 dp newtons, which I haven't written very clearly. So again, sorry about the putting everything in such a squashed up way, but I wanted to keep it all on one page, newtons. There we are. So the P force is 131.6 to 1 dp, and the angle is 75.2 degrees to 1 dp. Okay then, so that's 5-part. Oh, the whole of question 5 that is, isn't it? Because there's no A and B here. So that was the whole of question 5 done there. So that's good. So let's go on to the next question then. Great.